Hi everyone, this is an action potential recap part 2. Days ago, I posted my first video, and so this is now a recap of what we discussed earlier. So anyway, I'm talking about this action potential for ventricular muscle cell. I'm not talking about here the pacemaker action potential. This is an action potential of a ventricular muscle cell. So when we talk about this, we're only talking for one action potential. We talk only for one myocardial cell. When you say surface ECG in here, you're talking about the many cells that are electrically stimulated, and that reveals on the paper as a surface ECG in here. So going back to the action potential, going back to the cell. So you have a cell in here. Inside the cell are negative chemicals in here. There are proteins in there, there are phosphate, and they are not diffusible. So they stay there, they keep that inside of the cell as negative. But you're wondering why there's a potassium in there. Well, the potassium in there is positive, and that is the major player actually in the exchange and creating an impulse in here. So those are the electrolytes that are very significant, but they retain their positive, but the environment is negative, so the negative prevails. Outside the cell is the sodium, which is a major player. There are calcium outside and chloride, but what we're dealing with here primarily is the sodium in here. So this is the one. So when the sodium gets in, the potassium will come out. So they swap, and that's creating an impulse. So we will go to this action potential in here. And again, I'm talking about the ventricular muscle cell. So in here, this is an action potential of one cell that we're talking about in here. And if they group, and if there are many of them, then that is an ECG now. So again, there are stages involved in here in the action potential. We have this depolarization. First, we start with number 4, because number 4 is actually the polarization. When you talk about polarization, you're talking about a cell that is ready to be stimulated. That's number 4, and this is polarization. When you speak of this sodium in here, this is actually depolarization, and the sodium, which is positive, gets into the cell. So using a fast channel, there are doors in here that are fast doors, and this is where they get in. And then on top, we have the chloride and calcium. And these are the 1 and 2 now, because sodium is the 0. And we all know that the polarization is number 4. So if you proceed to chloride and that's calcium, they are 1 and 2. And they are the early repolarization. Okay. And if you get the whole stretch from here until the end of the calcium in here, you're actually reflecting here a contractility here. So I will explain that when we go down below this picture. And down in here, this is the final repolarization. Potassium is coming out. So sodium gets in, potassium comes out. This is just few thousand of a second in here. So that's how quick it is. So going back to these stages in here. So the stages in here, or the phases of this action potential, again, going back. So number 4 is polarization. Number 4 is polarization. That's there. Okay? And that means the cell can be stimulated anytime. If you go to number 4, that is depolarization, or the QRS in the ECG. Let's go there. That is the sodium entry. This is the depolarization. Sodium is getting into the cell. It's getting into that cell. Okay, then we have also 1 and 2. That is the early repolarization, and that is the ST segment on the ECG. But if we look up here, the action potential, 1 and 2 is the early repolarization. It's way up here. Okay, and actually if you talk about mechanical, because these are all electrical stimulation, that is actually the contractility side in the heart. But I will explain down below if we get to the picture of the ECG. And then number 3, that is the final repolarization in here. That is potassium. The final repolarization, that is potassium. It's coming out, and then go back again. Okay, and then go back in. But you are wondering, how will this chemical do their job, or how will they get out, how will they get in? Well, sodium will get into the fast channel. It's very fast. And then this calcium, they got also their doors or gates to get in. There are slow channels. Actually, halfway of the depolarization of the sodium, this calcium is already getting in, but it is a slow channel or a slow door to get in. And then this one too, the potassium comes out. We have also those pumps. They allow them to go out, the sodium potassium pump, and then so that they'll be able to go out and fulfill what we call an action potential. Because an action potential actually talks about, action potential is equivalent to polarization plus depolarization plus repolarization. That is actually the equivalent of an action potential. So going down, so when we say depolarization, now let's talk about the ECG in here. This is the ECG. So depolarization in here, actually, when the sodium gets in, you see this QRS, okay? When you say repolarization here, you see the ST segment. So the ST segment comprises number 1, number 2. Okay, that is the ST segment. That is the calcium area, because we are talking about major players in here. We're talking about sodium, we're talking about calcium and potassium. They are the 3 major players in cellular electrical stimulation. And then that is the T wave, where we finish everything. So that means the impulse is done and it's over, and go back to the polarization. That means the cell is ready to be stimulated. So when you see the depolarization, that is the QRS. When you see the 1, number 2, that is the calcium, and that is the ST. That is the ST. And then T wave, that is the potassium, sometimes with magnesium in it. But as again, we are talking about the major players. Now, because there are gates involved in here, we talk about sodium having a fast gate or channel. And we talk about the calcium, which has a slow channel. And we talk about this one has another channel. Well, we have a sodium channel. We have a slow, this is a fast channel. The calcium is a slow channel. We have also this pump in here. They all work because of the magnesium. The magnesium actually split the ATP. The ATP becomes energy. And this allows everyone to come out using the pump and the gates that they get through. But usually, sodium and potassium is by pump. So this is the one that actually facilitate and control the in and out of these two together. But usually, initially, the entry of sodium is via that channel. And also this calcium, there is also a pump for this one, but there's also a sodium-calcium exchanger. So that's about it. Now, you're wondering, what is this thing here beside in it? Well, because we're dealing here with a ventricle, cardiac cell. We're not talking about pacemaker cell, because pacemaker cell has also an action potential. In here, you notice too that we have a minus 17 here. This is the threshold voltage of this cell that allows the sodium to open up and everything. So when there's a surge of sodium trying to get in, this is actually the voltage in here, and they all get through, they open, they all get through and everything. Okay, and the pacemaker cell again is different, but this is what we normally use when we talk about action potential. This is what we are really talking about, at work in the CCU, and also regarding our, antiarrhythmic drug. The antiarrhythmic drugs are all based on all these chemicals. These are all the chemicals that they are trying to control in here. So one cell of myocardial ventricular cell, this is the action potential of the ventricular cell, and this is the threshold voltage, and that is the threshold voltage. I make it closer look. And these are the phases of our action potential, and this is the ECG of the action potential in here, and then that is reflected on the surface ECG, and then I guess basically I covered as much as I could. So I guess that's about it. So have a nice day, everyone. And our next topic now will be ECG. Thank you.